Welcome, ladies and gentlemen. So what I'm going to do for this problem is now I'm going to, when given a 0 of -4, I'm now going to determine all the remaining zeros. So to do that, when I'm given a 0, I'm going to want to use my synthetic division. So I'll set up synthetic division, and when we're using synthetic division, we make sure that we take our 0, if we were given a factor. If I had a problem that had a factor, we're going to want to make sure that we use the 0 on the outside, and then I take the coefficient of each and every one of my terms and line it up. So I have 3, 34, 72, and a -64. Now make sure if we're missing any terms when we go down descending order, that we want to make sure we fill them in. But in this case, I'm not missing any terms, so I'm just going to go and line up all my coefficients. Now when applying synthetic division, we always bring down our first term, and then we multiply diagonally. 3 times -4 is going to be a -12. Then 34 plus -24 is going to be positive 22. Then 22 times a -4 is going to be a -88. 72 plus -88 is going to be a -16. -16 times a -4. -16 times a -4 is going to be a positive 64. When I add vertically, I get a 0. So this, as my solution, is now going to be my resultant factor. If I was going to change the 0 as a factor, I would write it as x plus 4 as a factor. And what this means is if I was to divide x plus 4 into this polynomial, this would be my resultant factor. So it divides evenly, so I have a remainder of 0. I have a constant, -16, a linear term, I have 22, a coefficient of my linear term is 22, and a coefficient of my quadratic term of 3. So what I'm going to do is I'm going to write this resultant factor. So we know that x plus 4, that's one factor, and then I have a resultant factor of x squared plus, 3x squared. You got to remember those coefficients. 3x squared plus 22x minus 16. Now I could write this all set equal to 0 because that's what I want to do. I want to find all the zeros. All right? Well, we already know that x plus 4, that creates a 0 at -4, but I want to see what other zeros do I have for this. So therefore, what I'm going to have to do is factor this a little bit further. So if I was going to do that, I have x plus 4. Now to factor this further, I'm going to have to break this down into two different binomials. And I know that my first two terms is going to be 3x squared and, 3x times x. Then I know my last two terms have to be negative, or at least one of my factors has to be negative to multiply to give me 16. So there's a couple different options I have for 16. I could do 16 and 1. I could do 8 and 2. Or I could do 8 not 2, 8 and 3. Or I could do 4 and 4. And whatever terms I choose from outside of here, I need to multiply the middle and the outside terms to be able to add up to give me a positive 22. So when looking at this here, let's just kind of do some work. So if I did, and remember one of them has to be positive and one of them has to be negative. And it was 8 times 2. What am I doing? For some reason I was thinking 24. And that works out perfectly because if I have a positive 8 here and a -2 here, these two binomials will multiply to give me this trinomial. All right, you can apply this by using FOIL to make sure. But now, ladies and gentlemen, you can see I have a set of factors which I can apply the zero product property for, which I already know x plus 4 equals 0, that's a 0. 3x minus 2 equals 0, and x plus 8 equals 0. Therefore, we already know x equals -4 because that was given to us in our original problem. And then here, to solve for x, I add the 2, divide by 3, so x equals 2/3. And over here, x equals -8. So there you go, ladies and gentlemen. That's how, when given 1 0, to find the remaining zeros. Thanks.